but the accuracy unit gives better result in classification, and EWFNet gives better result in detection. So in introduction, we have again explained why the existing papers were poor in generalization and existing detection methods, and there were failure in generalization, artifacts detection, and why this new paper was proposed, because we were incorporating the more generalized form methods and multi-scaling features, etc. In the literature review, there are before methods like data sets like GAN generated images, deepfake data set. These were poor performance and giving less accuracy. And the new data set which were incorporated in the paper, in the proposed paper, which were AI generated data set and the computer produced data set. Both were giving more accuracy, and as you can see, and the research gaps were still the same as we have discussed earlier: poor cross-generator performance and generalization issue, and there were overfitting issues, all of those issues, and these were identified in the proposed paper, and these proposed paper has tried to resolve those earlier problems. Come to your proposed work. Whatever you have done. Yes. Come to your problem formulation. Yes, these are the methodology. Like I have said, there are two data sets which have been downloaded from Kaggle, the free data set, and these data sets are AI generated and computer based data sets. And we have two methods which are working on.
किस नाम से?
475.
This one?
Yeah.
Yes.
Okay, so I research like a background processing in Apache Kafka for real-time data integration, scalability and performance assessment. So in this research, I firstly introduce that we take a small type of data for real processing, like a banking processing, in which we including all the networks like a MasterCard, Visa, Amex, Pulse. So in this way, that whenever any customer come, any vendors and swipe their card, so it can be integrated and the whole transaction life cycle can be work. So in this paper, I just belonging this type of topics and the research. So I requested to like enter a next page. So in this way, we can divide it, our presentation in some of the lines, like abstract introduction, then literature review, that all we know that this is our the main PPT guidelines. So I request to enter our next one for the abstract. So as you know, many of companies are not to be handled more of the data because it is lagging old technology. So in this way, we can take a more fast and correct decision for a large data set to integrate batch processing and real-time integration, because in like old research, we just processing our data in a batch. But for now, it's time to quick and we get everything in a minute. So the transaction would be present in our day-to-day life. Whenever you swipe your card, your balance is deducted. So the main purpose of these is that I give a one example, like you going any DMart or any Reliance Mart and swipe their card, like your Mastercard, Visa card, Amex card, any credit card you want. So the transaction would be travel. So whenever you swipe your card, it is would be a any acquiring platform like a DMart or any Reliance Mart or any of other marts. So whenever you swipe your card, there is a one issuer side and one of the acquiring side. Issuer is that particular side whenever that your card to be issued any bank like SBI and ICIE and any World of Bank or in like USA, most of the customer are using credit cards. In India, there is no one like much using credit card, but in USA, Atlanta, and any other Columbia cities. So in this area, customer are using credit card and purchase. So in this way, the life cycle is like moving. So whenever he purchases any item, so it come to any networks like a Mastercard, Visa. So whenever it travel, like moving like swipe their card, so the request go to the Mastercard and when it give to our acquired bank side. So the transaction life cycle is processing. So I just researched that whenever any transaction come in our system, whenever provide we like a issuers, whenever I provide my system to any issuer bank like SBI. So SBI using my software in which we handle all over the transaction life cycle for every networks like Mastercard, Visa. So in which way there are multiple of data are coming in our real time. Because in today's time everything is in our phone. So whenever you tap your phone, whenever you swipe your card, so the payment would be frequently and give your result and tap your message, your money is deducted. So this is very frequently, but in a later time it is not in this way, like it give a state bank processing and the passbook system, but now time everything is in our phone within a minute. So these processing why it is most frequently. So my studies belongs to that, like I'm using Kafka for real time integration in which no, in which whenever transaction is coming in our system, so we divide it into our different modules like a microservices. First we validate their transaction like their CVV, card number, their PIN, and their ARQC. There are many methods in our Mastercard that whenever you read any Mastercard document or the Visa document, so there are very fields and data parsing fields like card number, uh, D3, D4, the processing number, the card number, the AQRS number. There are very of the fields are coming in that particular Mastercard document. So I just read the particular things and analyze their data, and we design microservices. So the first our microservices is validate all over that particular transaction, like whenever any transaction is coming in our system. So firstly validate the transaction, that is approved transaction or a declined transaction. Whenever our card is not correct, their CVV is not correct, so we just be response back to there is a failed transaction or there is not be a successor transaction, or if it is a successor transaction, their balance would be updated frequently at particular time. So we introduce Kafka for that because that transaction is approved and they went to the Kafka queue. And our next microservices, that is a balance update microservices. So in background, it update our balances frequently. So all over the research, I have launched to that particular things. Whenever any transaction is approved or declined, the balances should be updated at particular thing. So I request you to move next. So in this real-time data processing, solve that a batch delay problem that is earlier I am facing. So I can handle as soon as it is generated, helping organization respond quickly and improving system efficiently. Like whenever any transaction is coming or whenever any vendors is, you know that like आपने कभी क्रेडिट कार्ड यूज करा है इधर मैंने जो भी बैठा है एनीवन यूजिंग क्रेडिट कार्ड सो आप जानते होंगे कि लाइक अगर आप कहीं भी क्रेडिट कार्ड यूज करते हो तो उसका बिल 1 मंथ बाद जनरेट होता है ओके सो जब वो 1 मंथ बाद जनरेट होता है तो उसका एक सेटलमेंट होता है तब वो पूरा प्रोसेस होता है उसकी जितनी भी लाइक ट्रांजेक्शंस वगैरह होते हैं वो उस टाइम में प्रोसेस होता है तो
Sorry for interference, but 8 minutes has been passed. Now only 2 minutes are remaining for your presentation.
okay okay
Yes,
so
but 10 minutes है ना per person.
8 minutes has been passed. Only 2 minutes are.
okay, no problem. So I just quickly finish. Like in this way, we can process our every transaction. Like firstly, we are batching processing, but there is no more batching processing. The money is processed within a second for for this experiment. So I move to next the slide. So I can review the literature papers. So in this literature review, I study many of the papers working in a different work on the Kafka like a weather forecasting and the Zomato and the food related in a background processing for the transaction payment. So I can review these paper and I am working on a transaction way in a different for using. Move to next. There are some research gap that I can analyze is in a literature review, like in traditional data processing system work in a batch, but in so it would be a delay in data analysis. But in a model application require a real-time data processing to make a quick and accurate decision. For the existing messaging system facing some challenges like a high data volume and the scalability and the fault tolerance. But in R, we are using modern tools like a Grafana and for the study and the logging purpose. So it give a low fault tolerance and the scalability. Now moving to the next slide. Okay, the objective of this purpose is that we can process like Apache Kafka using a different performance metrics like transaction processing, weather forecasting. So we can analyzing that master card visa.
Now it's time for Q&A session.
Okay, no problem.
Just you have 1 minute extra. Focus on your main.
Okay. So the main focus is that like we are processing a transaction in a real time. So whenever update your balances quickly, so we are using Apache Kafka because it is a background processing. So it can quickly update our balances or whenever any balances is not updated and whenever transaction is not processed. So we can push that particular data in our DL queue. So this Kafka is also provide me to whenever it reproduce again, so our transaction is not lost. Whenever topic is up, so it can be processed. So main purpose of this is that. So thank you for listening me.
Any result analysis?
Yeah. You can.
Ask.
No. The result.
Yeah.
Yeah, so you can show that the result is when we're using a Kafka, we increase 45 1,000 transactions within 45 seconds. Or when like the fault tolerance and the latency is a minimum 10 to 12 milliseconds, and it improve our CPU utilization about 15%. So whenever you use Kafka, it give a better result. So this is my study. And like a fault tolerance also like a 3 to 5 seconds after broker fail. If any broker fail, like we create a topics in that. So and whenever any broker are fail, it due to a DLQ, or whenever a broker is up, so the DLQ is coming and process our transaction whenever the service is up. So no data is like a failed or lost. Yeah. Any questions?
Any more questions?
Like a transaction life cycle and any of that, like, so you can ask.
As you are working on the big data,
Yeah.
how to increase scalability?
Yeah.
And how to partition the, you have mentioned partition.
Yeah. So I'm working on a big data like 1,000 transaction coming in a 1 second in our system. So I arrange like Kafka provide different topics division in their partition is also there. So we can divide topics into a partition. So it can handle our load balancing and that particular thing to manage the data integrity and scalability.
How you balance the trade-off between fault tolerance and working? Right one and so there is a balance.
Yeah. So whenever any transaction is coming topics, so we divided our different topics for managing because Kafka provides me a topic and the partition to balance all over the transaction. So whenever we provide any microservices, you can belong these particular topic. So whenever any transaction come in our system, so it come to that particular topic because he knew that we can consume that particular transaction, not other. So whenever any transaction are lost or like fail, so it come to our DLQ. Like retry mechanism. So whenever any transaction are lost, we can retry 1 and 2 time. So in which way we cannot be lost our transaction or like it can also manage the scalability and fault tolerance as well.
Any specific metrics to evaluate this model? What are vision?
Like
How do you evaluate your model is working or what are the metrics you use? Is accuracy measures?
Yeah. So I use a matrix. It is about
how you say that your Kafka model is a better than
yeah, because I am working in a different metrics like a rapid MQ. This is also a message processing thing. So I compare rapid MQ and Kafka. Kafka is a modern and transient way. So in we can compare the rapid MQ message and the Kafka message. So rapid MQ is a very like a latency gap and fault tolerance. But in Kafka, we didn't face any of these things. So I just compare both of these.
Thank you.
Thank you.
Thank you.
Next person.
Thank you so much. Next, I would like to invite Dr. Prashant Kumar Srivastava sir to present a hybrid machine learning framework for intelligent loan approval prediction. Please put your hands together. For presentation, there is only 10 minutes and 5 minutes for Q&A session.
So which number? Paper number.
5 to 7. 5 to 7.
Good afternoon, everyone. I am Dr. Prashant Kumar Srivastava, from IEEE Bhopal. My research topic is a hybrid machine learning framework for intelligent loan approval prediction. Yes. These are the outline of the PPT. Basically, in this work, focus on the developing intelligent and reliable machine learning framework that assess financial institutions making fast, more accurate loan approval decision. Next. Next question. Financial institution process thousands of loan application every day. Traditional manual evolution and often the time consuming inconsistency and human errors, which may be increase the financial risk. Machine learning is an efficient learning from the historical loan and record by the analyze the applicant information such as income, credit history, loan amount, repay amount paid, predicting the model can be assist making the determine whether the application likely to be approved and rejected. These are the literature review. Research objective. Yes. Research objective is the to develop the enhancing the machine learning framework intelligent approval prediction to perform the comprehensive data processing features to compare the XP gradient boosting, cat boost using the same data set and evaluate the methodology. Access the model to performing predicting banking and metrics belong the simple classification accuracy. Yes. These are the methodology to we utilize the dream of housing finance data set of 614 loan application. Pre-processing stage include the finding the missing value, data normalization, standardization, feature engineering, include the total income loan to be a income ratio. We use the exit boost and gradient boost and cost cat boost algorithm to performance of separate test in 169 loan applications. Next, result and discussion. We use the three main algorithms: cat boost algorithm, gradient boost algorithm, exit boost algorithm. In cat boost algorithm, accuracy is more than and high. The gradient boost algorithm accuracy is 86%, and exit boost algorithm is 84 accuracy percentage. Next. In conclusion, in the proposed hybrid machine learning framework demonstrate to cat boost outperform our other evaluate boosting algorithm for loan approval prediction. Important emphasize the decision as a decision support system testing from of a loan officer, then replacing the human expertise. Research our plan to validate the framework, large multi-banking data set, integrating the AI techniques, and improve the transparency of clean every loan approval and rejection documenting. Next, these are references. Thank you. Any question?
So I have one question. Does it include only quantitative attributes or qualitative attributes also?
Quantitative attributes.
For example, there is one bank says in his advertisement, we see near, हम near देखते हैं. अब वो कैसे अगर उसको हम इसमें implement करेंगे? Quantitative attributes तो बड़े आसानी से include किए जा सकते हैं, incorporate किए जा सकते हैं.
एक्चुअली उस पर जो कस्टमर है, उस कस्टमर का पुराना हिस्ट्री अपन चेक करते हैं कि उसका हिस्ट्री, उसका लोन अप्रूवल किस बेस पे करेंगे कि वो कितनी बार उसने है ना प्रीपे किया है, और उस बेस पे अपन उसको है ना लोन अप्रूव करेंगे.
Okay. Basically, some attributes are quantitative attributes in the form. Suppose we fill the form in the bank. Some attributes are quantitative, some attributes are qualitative. So how you convert means how to apply the processing task so that your classification work.
कस्टमर की हिस्ट्री से ही वो उसको जस्ट कर
And one more thing, it is an imbalance because 90% customers have returned the bill, but 2% are defaulter. So there is a data set is imbalance data.
यस सर
There is a major challenge in the admission. So majority maybe 98% is good customer and 2% is maybe different also. So have you studied about the imbalance data? आपने कभी सोचा कि ये जो डेटा सेट आपने दिया है ये इम्बैलेंस हो सकता है?
बिल्कुल सर हो सकता है और इसकी
or any specific algorithm or to just apply a execute or means have you fine tuned the execute parameters आपने उस parameters को fine tune किया सीधे apply कर दो
नहीं फाइन किए सब पैरामीटर्स
कौन से parameters
कस्टमर की हिस्ट्रीज दिया है देखा है उनके कस्टमर की जो भी हिस्ट्रीज है रीपे की ये हिस्ट्रीज है और कस्टमर का अदर बैकग्राउंड डिटेल जैसे ना वो पेमेंट करने के लिए वैलिड है कि नहीं है अगर कोई कस्टमर ने सपोज होम लोन लिया है तो उसकी बैकग्राउंड डिटेल अपन फाइंड आउट किया है
how execute is different from the other traditional any traditional algorithm any machine learning because you have to isolate so you have to combine
यस सर
any advantage of this execute that's why you are very good with execute and accuracy is also very good and simple techniques
नो
Anyone question?
Thank you.
Next participant.
Thank you so much, sir. Our third presenter is Vishwas Engel, sir, presenting on IoT and cloud computing based framework for precision agricultural monitoring and prediction. Please put your hands together for sir.
Good afternoon, everyone. Myself Vishwas Engel. I am a final year BTech student at MITS Gwalior, and my paper is IoT and cloud computing based framework for precision agriculture monitoring and prediction. So first, let's do introduction. Next page, introduction. Firstly, as we all know, India is a very agriculture-based country. So, and it is done on very large scale. It is a fundamental part of human civilization. And what are the challenges in modern agriculture? Firstly, with a rapid growth in population, agriculture is facing challenges such as depletion of natural resources, climate change, and changing customer demands. And these factors require more efficient and sustainable agriculture practice to maintain productivity. Firstly, nowadays farmers which are using traditional methods, there are sometimes there can be discrepancy in their usage. Like they use more of fertilizers than it should be used. For that accuracy, we are building this model. Role of IoT. Firstly, IoT sensors which are used, many sensors are there. We will integrate that sensors in the fields and with the accuracy of their data, what data that is giving on that base, predictions are done and the prediction is shown to the farmers on how to do that, how much water is needed at current point of time in the fields. So next problem statement. What is the research gap and why there is a need to do that? Firstly, lack of real-time farm monitoring. Traditional farming practices rely heavily on manual observations and the experience of farmers which they are carrying from years, which sometimes lack a little bit, and inefficient resource management. Farmers often apply water, fertilizers, and other resources without precise information about soil conditions. At that point, current point, what is the exact needs of that soil for a better yielding of crop? And many farmers do not have access to technological tools that can be analyze environmental data and provide insights. Without proper data analysis, it becomes difficult to predict suitable crop or make informed agricultural decisions. And what is the need for smart and sustainable agriculture solutions? With increasing population and climate variability, climate is now also like global warming is increasing, and there are many climatic changes from past years that has been changed. For that, farming methods should be more efficient to be done, and there is need for intelligent systems that integrate IoT, cloud computing, and machine learning, which are modern used very much. And the related works, there are related works done on this, but not exactly completely. The related work done is based on historical data that are collected, and on that based this prediction. And what we are doing is collecting the data, live data collection and live processing for the better results. Methodology. Let me explain methodology in short. Okay. What we are doing, you can say a small device which is integrated in the field, which contains all the sensors required for the correct predictions, and that the sensors will collect the data like soil moisture. NPK sensor is used for the fertilizers contents that are present in soil, the moisture and temperature sensors, fire detection sensor, these all are integrated in a device, and that send the directly data to the cloud. The cloud pre-process the data, clean the data, missing values, there may be some missing values, and all pre-processing is done. Then through Blink, the model, the prediction is done, and through Blink IoT platform, we can provide app or websites, anything to the farmers. Through that, they can see what is now have to done. Like if there is जैसे पानी कम है मान लीजिए अभी अगर सॉइल में, और उसमें जरूरत है, जितनी जरूरत है वो फार्मर्स को बताएगा कि हाँ अब आप इतना ही पानी डालिए, ना एक्सेस होगा ना कम होगा। फर्टिलाइजर्स में कितनी नीड है, सॉइल में कितना पहले से प्रेजेंट है, हमें अब और कितना यूज करना है, ये सब चीजें फार्मर्स को आईओटी प्लेटफॉर्म्स के थ्रू बताई जाएगी। सिस्टम आर्किटेक्चर, okay, this is the system architecture we can see in the diagram. IoT sensors, then gateway point that is pre-processing of data, then cloud platform with data storage and analytics, and then IoT platform that is app, which is just a display of what is shown to the farmers. And the result and description. Okay. And the results and description: temperature, humidity, soil moisture, NPK, water flow, and fire detection sensors continuously monitor farm conditions. Data is stored in cloud database, and data pre-processing. Okay. Feature selection using nutrient analysis through stacked bar charts, soil moisture analysis using box plots, and correlation analysis to study relationship among environmental parameters. Next. There is a graph and some data sets that are the values collected by the sensors in the data, and this is prediction based. Next conclusion. How much time? In the conclusion and future work. So this is a framework. Main focus was designed on integration of IoT with machine learning. And in the future work, we are planning to do it on large scale. It currently is for very small scale work done, and we are planning to for a large scale smart agriculture systems. And references. These are references and thing. Before ending the presentation, I would. This was my. Thank you so much for Bansal Institute. This was my very first research conference, and I expected the presentation to be very good, but that's not how it went. Uh, Whatever it is, I will try to improve my skills and in the future. Thank you so much. Any questions, sir, and respected everybody sitting here?
Okay, so like IoT is very expensive, and not every farmer is like used to using mobiles, or some use that keypad one also. So
Yes.
how will we making this work for everyone? If not every farmer is educated.
That's the main issue here, because normally विलेज गांव में फार्मर्स होते हैं वो उतने पढ़े लिखे वगैरह नहीं होते हैं और ना उनके पास इतने टेक्नोलॉजिकल यूज तो नहीं होता है. उनके लिए हम ऐसा कर सकते हैं जैसे कोई एक ऑपरेटर है जो बीच में एज ए मीडिएटर काम कर सकता है, जो उनको सर्विस प्रोवाइड कर सकता है, बट लेकिन क्योंकि उनको यूज नहीं आता तो एज अ सर्विस प्रोवाइड करके उनको इन्फॉर्मेशन दे देगा और फिर वो उस बेस पे काम कर सकते हैं. तो उनको सर्विस भी मिल जाएगी और उनका खुद का वो एज अ रेंटल यूज कर सकते हैं, जो भी थोड़ा बहुत एक्सपेंस करके कर सकते हैं.
It is not feasible कि operator भी करके अभी आपने बताया ना कि agriculture में costing हो रहा है. And one more thing, in India there is a connectivity issue. Because you collect the data from the IoT sensors and then upload in your cloud network, where you have to predict and then transmit and then convert into the either text or voice format. So there is a connectivity issue. So how you handle that?
The connectivity sir, between farmers and the data.
Not your IoT device and your cloud network. So जो आपका IoT device है वो इंटरनेट से कनेक्ट होना चाहिए.
Okay. अब नेटवर्क की बात कर रहे हैं हम. सर वैसे तो आजकल सब जगह नेटवर्क से मिल ही जाता है.
One more concept is there. There is a time channel concept. आप एक डिवाइस ऐसा बनाएं जिसमें इंटरनेट की जरूरत नहीं पड़े. और decision making is also in a voice format.
Sir, we can try decision making. We can give language supports like Hindi, English, and every regional language we can give so that every farmer can understand it very well. And with the network problem, we will definitely try to look after it in the future once.
Okay. And we congratulate for your first.
So thank you so much, sir.
Thank you.
Thank you so much. Up next, I invite Drishti Jain ma'am for her paper, A Deep Transfer Learning Framework Using Pre-trained CNN Architectures to Classify Tomato Leaf Diseases. Please put your hands together.
Good afternoon, everyone. I am Session-1 from IEEE Bhopal, and today I am presenting my research paper titled A Deep Transfer Learning Framework Using Pre-trained CNN Architecture to Classify Tomato Leaf Diseases. The main objective of this research is to develop an accurate and computational efficient framework from automatic tomato leaf disease classification using deep learning transfer. Deep learning. Next. The outline of this presentation is as follows. Please, next. So, abstract. Tomato is one of the most widely cultivated vegetable crop, but it is highly susceptible to diseases that reduces both crop quality and farmers' income. Traditionally, disease detection is performed manually by agriculture expert, which is time-consuming, expensive, and often inaccurate due to human errors. To overcome these limitations, I have developed a deep transfer learning framework for automatic tomato leaf disease classification. For this work, I used a publicly available dataset containing 32,000 tomato leaf images belonging to 11 classes, which include one healthy leaf class as well. Before training the dataset, the images were resized, normalized, and for the model robustness. I implemented two pre-trained deep learning models, MobileNet V2 and a residual architecture and compared their performance. Among the two, the proposed residual model achieved the highest accuracy of 97.76%. Next slide. So, for the introduction, agriculture is one of the most important sector for food security, especially in developing country like India. Tomatoes contribute efficiently to the agricultural economy. Some diseases like early blight, late blight, leaf mold, and several other reduces the production if they are not detected at the early stage. Traditional diagnosis of these diseases are like time consuming, and also they are not exactly accurate. So we need a model that can detect these problems at a very early stage and help the farmers to like increase their income, and like the crops are very limitedly damaged. For the literature review, please. So these are the literature review that were previously done. Like the mobile net CNN was also used, but that performed 95.79% of the accuracy. So from the review, I observed that although many models provide good classification accuracy, they often suffer from high computational complexity, dependence on handcrafted features, and limited robustness in real agricultural environment. Research gap. Despite recent progress, several research gaps still exist. Existing models require high computational resources, making development difficult on mobile devices. Many approaches still rely on handcrafted features, extracting and performance well under controlled laboratory conditions. They are not working well in the environmental conditions that are in the villages or where the growing of tomatoes is going on. For the next part. Okay, so based on this research gap, my objective was to develop a automated disease classification framework to implement MobileNet V2 and residual architecture, to improve accuracy using pre-processing and data augmentation, to reduce the computational complexity, to compare both architectures, and finally identify most suitable model for real-world architecture applications, agriculture applications. So please next for the methodology. So for the methodology, I have used the data set Kaggle Tomato Leaf Detection Database. It has around 32,000 images, in which there are 11 classes, 10 are disease classes and 1 is healthy classes. Then I moved to the image resizing and image normalization and all the processes for data pre-processing. After that, the model is developed, and we have used like both the models, MobileNet V2 architecture and residual learning architecture. And after that, we evaluated the accuracy, precision, recall, F1 score, ROC, AUC analysis. Next. So this is the methodology. Firstly, the tomato leaf data set is data pre-processing. It is went through resizing, normalization, augmentation, then data splitting works, and we have divided the data into training and testing. After that, the classification models are worked on the training and testing data set. After that, we have performance metrics, accuracy, precision, and the final result. Next slide. Okay, for the results, the accuracy of MobileNet V2 95.01 and residual is 97.76, and precision also, the residual works much better, like better over MobileNet V2. Okay. Both the models were evaluated, and I've also shown the accuracy curve, accuracy and loss curve for the models. Next. Comparison between different existing models, CNN, ResNet, G16, MobileNet V2, and proposed residual model that is highest 97.76. Next slide. So for the conclusion, to conclude this research successfully developed a deep transfer learning framework for tomato leaf disease. Image processing and augmentation improve robustness, while the proposed residual architecture achieved the best accuracy 97.76%. The framework is computationally efficient and suitable for smart agriculture applications. In future, we are planning to investigate transfer-based model attention mechanism, deployment on the mobile and edge devices, IoT integration, drone-based monitoring, and real-time disease progress analysis. Thank you so much. This is all about my presentation. These are the references that I used. Thanks. Any questions?
Any questions? You only pre-train the model or fine-tune the deep convolutional network?
Sir, we use the pre-trained model as the first model that was used, like the untrained model. We can say it uses it wants large data set and cannot be like restricted to a 32,000 images or something like that. So I use a pre-trained model for this purpose so that I can train it on a smaller data set and get better results.
And in the pre-processing, suppose we have collected the data set images, leaf images, you just pass on the already pre-trained model and then check it.
No, sir.
Now we apply some pre-processing, image modification, even some removal of the noise data. And then again we have
No, sir. It is like we get the leaf, images of the leaf, and then get into the corrections of the images like resizing or noise removal and everything. Then we send it to the model, pre-trained model. Thank you so much.
Thank you so much. Moving to our fifth presenter, please welcome Arpit Pandey sir for Federated Blockchain and Hybrid Deep Learning Framework (FBHDL) for secure and transparent agricultural trade. Please put your hands together.
Very good afternoon to everyone. I'm Arpit Pandey. So, topic of my research was Federated Blockchain and Hybrid Deep Learning Framework for secure and transparent agriculture trading, which basically means like providing end-to-end secure transaction and providing the transparency at the agriculture level. We are using blockchains, ledgers, and deep learning concepts for fine-tuning the models and other steps that are required to make things effective and efficient. So these are the outlines we have. Then we coming to the abstract part. FBSDL basically integrates blockchain, federated learning, and hybrid deep learning for secure digital agriculture. Blockchain ensures transparent, tamper-proof transaction and automates payment through smart contracts. Here, what it basically covers, tamper-proof means that we are using the ledgers here, which cannot be contaminated in between. And the automate payments through smart contract means like once the delivery is taken from farmer side and it reaches to the customer side, and once it's delivered at the customer level, with the help of a smart contract, we will be able to deliver it and the payment of the farmer will be processed then and thereafter. For federated learning products, former data by training AI models locally without sharing raw data. And for hybrid deep learning, predicts prices, validates transaction, achieving like 98% accuracy with high security and efficiency. Now introduction. On the introduction part, like we have like digital agriculture uses IoT, AI drones, satellites, smart farming technologies to improve productivity and decision making. And farmer face challenges like basically related to data privacy. Data privacy means like the product is being taken from the farmers. Previously, like the intermediaries contaminated the data, they basically change the expiry date and all those stuffs, and when it reaches to the consumer side, it basically it's not that healthy food that it need to be. So they blame the farmers that the product that they have sent that is not a good one. But when we are using the data privacy part, so only the people who are involved in the processes will have the accept of the address, and they can only change those address level part. We come to literature. So here in literature review, the focus was on like digital agriculture ecosystems and smallholder farmers. Methods that we use like systematic literature review, digital infrastructure gaps, affordability, low digital literacy. The key finding was for like digital agriculture can help smallholder access market and improve productivity. The contribution is like limited focus on digital literacy, like affordability, business model, innovation, research, agenda proposed. So these are the things that we have covered, like the classification based on the agriculture digital platforms and value chains. So basically, the challenges that this focus was like the lack of framework of categorized emerging digital markets. Next one. So and we have a digital transformation for like sustainable agriculture, and the challenges was here like the policy gaps, fragmented information, digital divide. So the key findings was to share data platform benefits, stakeholders, digital capability plus the infrastructure need. So the contribution was here of lack of systematic research linking digital technology with farmer level sustainable transitions. Next slide. So the research gap was like first the lack of secure and transparent data sharing mechanism that ensures farmer data ownership, privacy, and trust in digital agriculture platform. So before the farmers were facing the privacy issues, the data contaminated part, and the trust. So now like they will also be involved in the process. They will be having the access, and they can able to track the products from end to end, from where it start and where it goes. So the trust can be earned, and that helps in transparency part as well. The scalability challenges remain unresolved as many digital agriculture solutions perform well in like the pilot studies but fail during the large scale implementation that we are doing. We can move to objective one. Yeah, to enhance the transparency, security, and trust in agriculture trading using blockchain. So as we will be using the blockchain, the ledgers, so basically the smart contract, these will help to gain the trust of the farmers and to develop a model that ensures efficient validation of transaction with reduced latency, and also to integrate hybrid deep learning for improving classification of valid and broken links. We can move to method. The proposed system uses blockchain, smart contract, and deep learning to ensure secure, transparent, and automated agriculture trading. So this will have support transaction validation. So transaction validation we can cover like by the transaction validation will be like everything will be disguised. So the track of transaction will be there, so it can be easily validated, and the price analysis also will be same at the global level. It cannot be changed. So like the farmer can like previously what happens the they don't know the exact value of the product, so they might get mistrust issues. So that will help in the price analysis as well.
Sir, only 2 minutes are remaining.
Okay.
3 minutes has been passed.
Yeah, we can move next. Yeah, so here these are the constants that we have taken like the index, state, district, market, commodity, variety, and all these are the constant data constant that we have taken and analyzed in our deep learning concept. Yes. So the proposed PSDL model use like blockchain federated learning and hybrid deep learning to ensure secure transaction and decentralized model training. So basically the privacy protection and efficient price analysis are done. Like we have a decentralized model, so like everyone will have an access and will able to see the all the end-to-end cycles that are happening within the process. You can move to the third sentence. Yeah, for the model improves agriculture trading by increasing transaction accuracy, reducing latency, and enhancing throughput compared to traditional approaches. So we will have a more robust system now because everything will be tracked on the database part. So that will be more robust part, and the framework will be like the blockchain libraries that we have like Web3, Ethereum, and TensorFlow federated. So those will be using. As we can see, like in the graph here, the accuracy has been moved like to 90%, and the valid links with only like 10% are the broken links. Like most of the right now in the agriculture sector, some of the data that we have that is not that need yet to be trained. We need to apply SSL over here, self-supervised learning, to make it more accurate. Like it's 90%, but we can move to 100% or like 99.99%. As we know, like AI is not magic. It's a data flow driven concept which we handle like mathematically, and so we will work on that and will conclude. Okay, so we have a combined blockchain federated learning and hybrid learning to enable secure and transparent agriculture. The model ensures fair pricing, secure transaction, and reduced dependence on intermediaries, supporting sustainable agriculture. Yeah, references. These are the references that I use. Thank you.
I have one question because I'm also working on a blockchain in my one of the project. So one of the problem I faced like how does to maintain blockchain prevent double spending digital payment? How does blockchain prevent double spending digital payments? Like you are using payments for the agriculture and the so how to maintain like a double spending digital payments in a blockchain?
Double spending won't be happening much.
Spreading, not spending.
Spreading is payment happening two times.
No, no. Payment is going in a one way, not a two way. In our transaction lifecycle, it's going a one way in a blockchain. So how can handle this type of transaction in a blockchain?
In this model, basically we are having a nodes that are connected to each other, and the people who are involved in the process are associated with the nodes. Once the product has been started from the point, the transaction is being initiated from there onwards, and it's being in the pending state. Once it's receives at the receiver's end, then the payments happen, and that is the secured way to do it.
Okay, like I know the transaction life cycle, but my question is that how you are handled like a spreading thing in a blockchain, because I'm facing that problem in that blockchain like a lithium, you can say that in your conclusion part.
Spreading, I'm not able to like exactly analyze the word spreading here.
Okay, no problem. Thank you.
The question is related with the blockchain advantage. My question is how you optimize overhead, because you have to combine the blockchain, federated learning, and deep learning. The model is very heavy. Is there any optimization done Because there is no overhead.
Yeah, so basically we can the way the microservice layout architecture we are going to follow here. We won't follow the monolithic architecture over here. Every system that we are going to design, we can follow the libraries that are being used, the best optimized libraries like NumPy, Pandas that are used for data science learning part. So we can use that, and we will basically optimize our system by doing like horizontal scaling and auto scaling part we can introduce. Like if we have we are having a transaction like 10 to 12 transaction at a time. So but sometimes that may happen that transaction may increase to 20 to 25 or 100. So based on that we will keep on adding the virtual machines to it.
So I have also one question. Like you mentioned, you are using horizontal scaling for data preparing. So what type of database you are using for the horizontal scaling in a blockchain? Which type of database you are using to store data in a horizontal way?
Basically Postgres.
Okay. Like I'm using a popular DB that.
Thank you.
Thank you.
Thank you to all our presenters for their brilliant work. Now I would like to request our esteemed session chair, respected Dr. Sunil Joshi sir, respected Dr. Rajneesh Chaubey sir, respected Dr. Karuna Vidhi ma'am, to kindly come forward to distribute the certificates to our participants. First, I would like to call Swati Mishra ma'am. Next, I would like to call Dr. Prashant Kumar Srivastav sir. Next, I would like to call Vishwas Singhal sir. Next, I would like to call Drishti Jain ma'am. Next, I would like to call Arpit Pandey sir. Thank you all. I now request respected Dr. Rajneesh Chaubey sir and respected Dr. Karuna Vidhi ma'am to kindly present the memento and certificate to our session chair as a token of respect. Please put your hands together, everyone.
Now it is requested to all the
All participants, please
for
come
session
forward.
1.
Have a group photo.
Wait, sorry.
अच्छा अभी अच्छा करिए
आ जाइए इसके साथ आइए
सर इस तरफ आ जाइए क्या वो पेज थोड़ा सा
दोघे राहुल skills.
Thank you so much. With that, we wrap up the first session. I would like to invite respected Dr. Rajneesh Jogge sir, HOD MCA, to deliver the vote of thanks. Please put your hands together.
Thank you, Priyanshi. I take this opportunity to thank, first of all, Dr. Sunil sir, who has spared time from his busy schedule and motivated and guided and evaluated all the papers presented here. Next, I would like to thank the management and administration of Bansal Group of Institutes who have provided this opportunity to organize such a wonderful conference, and IEEE NT section who have provided technical support and sponsorship for this conference. Next, I would like to thank all the participants who have come a long way to present their ideas and research, and all the members who have supported in organizing this conference successfully, this session particularly. Thank you to one and all. Thank you. Now I like to request all the participants and session chair sir to move for lunch. Sir, please.
Okay.
इसमें कौन सा वाला है सेकंड सेशन
आप सबका
राजीव पांडे का अपनी नंबर की अपना है ना ये देखा था ये सेकंड वाला ये वाला नहीं ये तो सुन ये तो कल का ये भी नहीं तीन तो हम लोग किए थे इसको ये वाला आज वाला सेशन पे नहीं इसके आगे
सर आप सर्विस से चलिए
हाँ ये
मैम आपका हो गया लंच आप लोग बैठना सेकंड सेशन अभी मतलब 220 पे एक फार्मेसी और एक की नोट सेशन है वो फिर अपना 3 बजे से तो आप लोग फार्मेसी में चले जाइएगा फिर अपना 3 बजे
मैम एक बार पीपीटी ठीक से है क्या नहीं देखना था
मैम एक मिनट क्या आप बस 10 मिनट वेट करेंगे वो फिर क्या होगा ना वो इसका भी लंच है ना भैया मैं दीदी को भेजी तो यहाँ दोनों स्टैंड के अंदर वाले लगवा दीजिएगा फ्रेश
सेशन चल रहा है इस बार नेक्स्ट सेशन चल रहा है ये बैठी आज भी होगा आज सेशन पर